Bacterial resistance to ampicillin and growth rate of Escherichia coli is the title of Luiza's project. She is a student at the Lycée Michalucius and will now join us on stage for more explanations on her project. Good luck, Luiza.
Hello everybody, my name is Luiza and today I'll be presenting my project on bacterial resistance to ampicillin and growth rate of Escherichia coli. Starting with the aim and the hypothesis of the project, the aim was to investigate whether resistance to antibiotics can influence how bacteria adapts to different temperatures. And the hypothesis was that bacteria that had been in contact with antibiotics would have a greater growth rate than bacteria that had not been in contact at all, implying that it would have a great adaptation to different temperatures. The organism that I chose to study, as I've said before, is Escherichia coli, also known as E-Coli, and it's a bacterium found in the intestine tracts of healthy humans. It can also be found in other animals and plants as well. And the reason for why I chose this organism is due to the rapid growth, low maintenance, and is also one of the most studied and most understood microorganisms in research. When bacteria often have the tendency to develop defense strategies against antibiotics, and it is actually what I was counting on for my project, since I needed one of my colonies to be resistant to antibiotics in order for the experiment to be complete. And the antibiotics that I chose for this project is ampicillin. I used 10 micrograms ampicillin discs, also known as AM10. For the research, I began with the background information, which was the optimal temperature for E. coli growth, which is 37 degrees Celsius. Anything above that would cause the enzymes to denature, meaning that the metabolic reactions can no longer take place, and anything below that would simply slow down the metabolism due to the decreased amount of successful collisions between enzymes and substrates. As the antibiotics are introduced when the bacterial colony is growing, the bacteria has a great tendency of developing defense strategies to develop a resistance against it. And this could be by having restrict access, so having a selective outer membrane by not allowing the antibiotics to enter the cell. They could also remove the antibiotics that have entered the cell already by using pumps on the cell wall and simply get rid of the antibiotics. Or they could simply change the antibiotics target, because some of them are designed to attack a specific part of the bacteria. So if that part has changed, the antibiotics can no longer perform the task. For this experiment, I had 3 different variables: controlled, independent, and dependent variables. Control variables are the ones that I kept the same throughout the entire experiment. And that was the organism. I used a non-pathogenic strand of E. coli, so there is no risk. I also used the same agar volume and also the same LB broth volume. I used the same antibiotic quantities and the time the bacteria spent inside the incubators. For the independent variables were the ones that I changed, which was temperature. I tested the E. coli growth under 3 different temperatures: 25, 35, and 45 degrees Celsius. And for the dependent variable, which was the ones that I simply measured, which was the maximum absorbance, I measured by using a spectrometer, and for the plates, I measured the inhibition zones with a ruler. Now for the experiment. The materials I used were E. coli, as I've said already, non-pathogenic strand, Bunsen burner that allowed me to have an open flame throughout the entire experiment, and also the spectrometer tubes, the Petri dishes, and all the other materials that helped me to prepare the LB broth for the spectrometer tubes and the LB agar for the plates. This was the setup. As you can see, everything was managed around an open flame, and this allowed me to have a sterilized environment and avoid contamination as much as possible. Now for the procedure. The first step was to divide my Petri dishes and my spectrometer tubes and label them after sterilizing the table and my hands. I had 3 different temperatures, 25, 35, 45, and 2 different colonies, exposed to antibiotics and non-exposed. So per temperature, I had 2 exposed, 2 unexposed, and so on. Each plate was divided in half, and this allowed me to have 4 sets of data per colony per temperature, allowing me to have a more reliable results. After that, I began by pouring the agar on the Petri dishes and the LB broth on the spectrometer tubes. The reason for why I did not add agar for the spectrometer tubes is because the spectrometer needs a liquid medium to work, and that is why agar is not added. I waited for the agar to solidify on the plates, and then I began by adding the AM10 discs, which was the ampicillin, the antibiotics, on both the plates and the tubes. And then I placed them in the incubators according to their assigned temperatures. They were left in the incubators for 44 hours, and after I removed them, I recorded the results and analyzed. These were the results. In the first table, I'm showing the inhibition zones for the plates, and the second table I'm showing the maximum absorbance for the expectometer tubes. So from the table, I could conclude that 25 degrees Celsius was the optimum temperature for the bacteria to build up the resistance. Since the metabolism was lower, they had more time to adapt themselves. At 45 degrees Celsius, there was no growth of bacteria at all for both exposed and non-exposed bacteria, and that is because it was past the optimum temperature for the enzymes and metabolic reactions could no longer take place. For the maximum absorbance, the exposed bacteria had a greater maximum absorbance in all temperatures, and this means that the liquid in the exposed bacteria was more concentrated than the liquid in the non-exposed, because there was more bacteria inside. So this shows that the growth rate was greater. The conclusions that I got from these results was that resistance to antibiotics can influence how bacteria adapts to different temperatures. And the hypothesis that bacteria exposed to antibiotics would have a greater growth rate than bacteria that had not been exposed at all can be accepted, as the results were foreseen and expected. These were more sources that I used. Most of the information about E. coli behavior I got from the paper written by Mario Galinda Mendes, which was Resistance in Escherichia coli. Thank you very much for your attention. I'm looking forward to answer your questions.